Hey guys, today we're going to be talking about an introduction to matrices and some basic matrix operations. So to start off, let's define a matrix. A matrix is a rectangular array of numbers arranged in rows and columns. An m by n matrix is a rectangular array of numbers with m rows and n columns. So when I count my rows are going to start from the top of the matrix and work their way down. So this would be row 1. The row below it would be row 2, the row below that would be row 3, etc., all the way down to the bottom of your matrix. The columns go from left to right. So this would be column 1, column 2, column 3, all the way across. An easy way to remember your rows and your columns: people sit in rows, so those go across. Columns are those things that are in front of fancy buildings or the really big houses, so those go up and down. Columns. The way that we identify an element in a matrix is by looking at the subscript. The first number in the subscript indicates the row, and then the second number in the subscript identifies the column. So this element is in row 1, column 1. If I wanted to know which element was A23, I would be looking for the element in row 2 and column 3. So if I look at my matrix over here, row 2, column 3 would be whatever element was right here. Let's look at a couple more examples of identifying the elements in a matrix. So here is my matrix. This matrix has 1, 2, 3 rows and 1, 2, 3, 4 columns. So if I'm looking for the element A13, I'm looking for the element in the first row and the third column. So in the first row and the third column, the element there is 2. For A33, I'm looking in the third row and the third column, so that's 7. A21, second row, first column. Second row, first column, that's 5. A31, third row, first column, that's 2. A34, third row, fourth column, -6. And A42, fourth row, second column. Since there's no fourth row, this is undefined. There's no element there. We say that a matrix has dimensions m by n, where m represents the rows and n represents the columns. So in this matrix here, matrix A, I have 1, 2, 3 rows and 1, 2, 3, 4 columns. So this matrix has dimensions 3 by 4. It's going to be important to be able to identify the dimensions of a matrix when we do matrix multiplication. So that will be next, but we're going to practice identifying the dimensions of a matrix. First one, this matrix has 1, 2, 3 rows and 1, 2, 3 columns. So this is a 3 by 3 matrix. This matrix has 1, 2, 3, 4 rows and only 1 column. That's a 4 by 1 matrix. This matrix has 1 row and 1, 2, 3, 4, 5 columns. So that's a 1 by 5 matrix. This matrix just has 1 element, that's 1 row and 1 column, so that is a 1 by 1 matrix. Each of these matrices has a specific name. This matrix, since it's a 3 by 3, it has the same amount of rows as it does columns. That's called a square matrix. This matrix is called a column matrix because it only has 1 column. This matrix is called a row matrix because it only has 1 row. Next, we're going to look at a little bit more vocabulary. So we just identified each of these matrices: a row matrix, a column matrix, and a square matrix. So something that only has 1 row, something that only has 1 column, and then a matrix where the number of rows equals the number of columns. There's also something called the zero matrix. This is also known as the additive identity matrix and consists of elements that are all 0. So the additive identity matrix for this matrix here would just be 0, 0, 0, 0. So that matrix is going to have the same amount of elements laid out in the same exact way, but all of those elements will be 0. The additive inverse of a matrix has all corresponding elements that are opposites. So again, the additive inverse of this matrix will have the same amount of elements laid out in the same exact way. However, each of those elements will be opposite to the elements that are here. So 1, -9, -2, -7, +3, +5. That would be the additive inverse to this matrix here. The last kind of matrix that's important to know about is the multiplicative identity matrix. This is usually denoted with a capital I and is a matrix whose elements in the main diagonal from the upper left-hand corner to the lower right-hand corner are all ones. So you see this matrix has all ones along the diagonal. This matrix has all ones along the diagonal. The rest of the elements surrounding are just 0. Next, we're going to talk about the addition and subtraction of matrices and scalar multiplication. So when I'm adding and subtracting matrices, they must have the same dimension. This is very important. I cannot add or subtract matrices that are of different dimensions. When I add or subtract matrices, I'm just adding or subtracting the corresponding elements. So if I were adding these two matrices, element A and element E are both in the top left, so I would add those together. Element B and element F are in the top right. I would add those together. And I would do that for all of the elements in the matrix. I'm adding the corresponding elements together. And the same thing applies for subtraction. To multiply a matrix by a number, this is called scalar multiplication. And you'll see it denoted with just a number outside the matrix. This means that I'm going to multiply this number by every element within the matrix. So 2 times k, 3 times k, -4 times k, and 5 times k. Let's look at a couple of examples of adding and subtracting matrices and scalar multiplication. Number 1, I have 3 matrices up here defined by C, D, and E, and part A says to do matrix C plus matrix D. So I'm first going to write out matrix C. Then I have my plus sign, and I'll write out matrix D. Now that I have these written out, I can see that these matrices both have the same dimensions. They both have 2 rows and 3 columns. Since they have the same dimensions, I can add them. So now what I'm going to do is just add the corresponding elements, and my resulting matrix is going to have the same dimensions. So I know that my resulting matrix is going to have 2 rows, and I'm going to start adding. So 5 and 0 is 5. 7 and -7 is 0. 3 and 12 is 15. -2 and 1 is -1. 6 and 5 is 11. 1 and 2 is 3. There's my answer for matrix C plus matrix D. For C minus D, I would do the same thing. I would just subtract those corresponding elements. For C, it says to do 2 times matrix C and then subtract 3 times matrix E. Now when I do this scalar multiplication, I'm going to end up with a matrix of the same dimensions. And same thing over here. So now if I look at these 2 matrices, this matrix has 2 rows and 3 columns, and this matrix has 3 rows and 2 columns. So since these 2 matrices don't have the same dimensions, this is not possible. I cannot combine these matrices. Number 2. Solve the matrix equation 2x minus a equals b for the unknown matrix X. I see that matrix A and matrix B both have the same dimension, so I'll be able to do addition and subtraction between these matrices. I'm first going to start off with the equation that they gave me, which is 2x minus a equals b, and I'm going to solve for x the way I normally would. If I add a over, I get 2x equals a plus b. And then in order to get x by itself, I'm really going to multiply by a half. So I'm going to write this as x is equal to 1/2 a plus b. So this tells me that I'm going to need to add matrix A and B and then do a scalar multiplication of 1/2 of whatever that sum was. So let's do a plus b first. Here's matrix A and matrix B. When I add these together, I'm going to add the corresponding elements. 2 and 4 is 6. 3 minus 1 is 2. -5 plus 1 is -4. And 1 plus 3 is +4. I'm then going to do scalar multiplication of a half to this matrix. So I'm going to multiply a half by each element within the matrix. A half times 6 is 3. A half times 2 is 1. A half times -4 is -2. And a half times 4 is +2. You can also think of that as division, right? I'm just doing 6 divided by 2, 2 divided by 2, -4 divided by 2, etc. I'm going to skip around to the odds for the rest of this worksheet, so here we go. For number 3, I have a matrix minus a matrix plus another matrix. First thing I want to do is make sure that they're all the same dimensions. These are all 2 by 2 matrices, so I know that all of these operations can be performed. I then just follow my order of operations, so I'm going to work from left to right. So the first thing I'm going to do is subtract those first 2 matrices. 10 minus 8 is 2, 4 minus 6 is negative 2, 1 minus 9 is negative 8, and negative 12 minus 2 is negative 14. I'm going to then carry down the matrix that I'm adding, so negative 6, 13, 8, and 10, and now I'm going to add these by using the corresponding elements. Negative 6 and 2 is negative 4, negative 2 plus 13 is 11, negative 8 plus 8 is 0, and negative 14 plus 10 is negative 4. All set for number 3. Number 5, I'm adding this matrix with the matrix on the right. First thing I need to check is that the dimensions are equal to one another. It's very obvious that these 2 matrices do not have the same dimensions. This matrix has 1 row and 3 columns, so this is a 1 by 3 matrix. This matrix has 2 rows and 2 columns. It's a 2 by 2 matrix. So I cannot add these 2 matrices together since they do not have the same dimensions. Number 7 is just scalar multiplication. So I'm going to multiply negative 2 by every element within this matrix. So when I do that, I end up with negative 10, negative 6, positive 2, positive 4, negative 16, and positive 18. Number 9, solve for the missing variables. So when I'm solving for variables in matrices, what I'm going to do is try and set up equations with corresponding elements to help me solve for the variables. So I see that I'm adding these 2 matrices on the left, and the result is this matrix on the right. If I'm looking for x, I'm starting with that top left element. So that tells me that when I did 3x and I added negative 4, the result was negative 16. Again, I'm just looking at the corresponding elements in each matrix and the operation that's showing up between them. So I can set up the equation 3x minus 4 equals negative 16. And I would just solve the way I normally would. So I get 3x is equal to negative 12. Divide by 3, x here is equal to negative 4. I can do the same thing for y. So y is in the bottom left corner of my matrix. So that corresponds with the negative 7 and the negative 1. The equation that I can set up here is negative 1 minus 7 is equal to y. So I get y is equal to negative 8. That's it for an introduction to matrices and basic matrix operations. If you have any questions, feel free to leave them in the comments below. Hope you have a great day.